Hello, calculus students. So here's your accumulation video intro. There are two other accumulation videos that are already on YouTube. This is the intro that you should watch before them. And this is what we would have done in class, but due to the snow days, we have to make a video out of it. So this is going to introduce the whole idea of it, and it's going to start off your first free response in this video, and the other videos will continue with the free responses. All right, so you guys spent 2 days doing accumulation packet number 1 and accumulation packet number 2. And what you should have realized by the end of that is that whenever you have an integral of a rate with respect to time, that integral will give you an amount. And we're going to be emphasizing that over and over again in these videos. So let's consider the following situation. So you don't have to write anything down yet. I just want you to listen and to think here. So for the following situation, we're going to be starting 20 miles north of the house. We're going to travel north for 2 hours at 60 miles an hour. Then we're going to travel south for 3 hours at 30 miles an hour. So I'm going to say that again. We're going to start, so here's our house. We start 20 miles north of the house. You travel north for 2 hours at 60 miles an hour, and then you travel south for 3 hours at 30 miles an hour. Now there's a lot of questions you could ask about this situation and many different answers that you could come up with. You could ask how long you traveled, how many hours. You could ask your distance traveled, your displacement. You could talk about speed, etc. The one answer that I'm interested in is the answer 50 miles. Now I want you to think, would you be able to come up with math to get this answer? And do you even know what question would get you 50 miles? So let's think about this again here. This says 60 miles per hour for 2 hours. Now, units are the most important thing that we're going to be doing today. I'm going to say that several times. If you don't know your units, you won't be able to answer these questions. So everything's going to have a unit. It's not finished if it doesn't have a unit. Then you're going to go south at 30 miles per hour for 3 hours. So I want you to pause the video for a minute, and now I want you to write out the math in order to get 50 miles. And then I want you to think about, like, what does 50 miles even represent? So pause the video here and come up with the math in order to get the answer of 50 miles. Now make sure you take the time to do this, because if you can do this, then you can do any accumulation problem that AP throws at you. So go ahead and do that. All right, so you should be back, and what you should have come up with is that in order to come up with 50 miles, you should have taken your initial condition of 20 miles. Then you should have taken a rate, 60 miles an hour, multiplied it by 2 hours. And then, so 60 miles an hour for 2 hours gives you the distance north that you've traveled. So you've gone north 120 miles, because those cancel. And then what you do is you go south, which is why you subtract 30 miles an hour. Going south is a negative rate for 3 hours. Your hours cancel. That means you've gone 90 total miles south. So this is your distance south. All right, so I have 20 plus 120 minus 90. These are all miles. And this will give me 50 miles. So I started with rates. That is a rate, and that is a rate. And then by multiplying a rate by a time, I have turned it into just miles. I went from miles per hour by miles. I went from miles per hour to miles by multiplying by a time and canceling the hour. You're going to have to be able to do something similar to this. And this is really the whole setup for accumulation. You take your initial condition, you have a rate, and you have another rate. So this is a positive rate, and this is a negative rate. You do stuff with the rates, and then you end up with a final amount. Miles, this is an amount, this is not a rate anymore. We're going to want to turn this statement into a calculus statement though, because again, this is a calculus class here. So let's think about how we could turn this into calculus. Now, another thing is let's think about what 50 miles even represents. 50 miles here is your ending position with respect to the house. So you started 20 miles north of the house, then you end up 50 miles north of the house. That's where you finally park your car. So we're going to take our statement and turn it to calculus. So what I want you to do is take this statement that I circled right here, and I want you to rewrite it in calculus talk, more specifically with an integral or integrals. So why don't you pause the video and give yourself a chance to write it out. Don't just copy down what I'm doing. Give yourself a chance to write this with integrals. Go ahead and do that. So make sure that you've paused the video and you've given yourself a chance to try it out on your own before just copying mine. So we have our initial condition. That's just an amount and it's in miles right now. Remember, to end up with miles, we need to be working with miles. So here I have a rate. And remember, in order to go from a rate to an amount, what we have to do is an integral. An integral of a rate gives us a net change in the amount. So instead of having to do 60 miles an hour times 2 hours, what if we did an integral of 60 miles per hour times dt? And I'm going 60 miles an hour from what hour to what hour? Let's see, that was from the beginning up until 2 hours later. Okay, so then I'm going to subtract going south. That would be, I started at 2 hours and I did it for 3 hours, so it goes until the 5th hour. And that would be 30 times dt. Let's check our units, because again, units are the most important thing we're going to be doing today. So these correlate and these correlate. Alrighty, so 60 is in miles per hour. dt represents the infinitesimally small time, which is in hours. Those cancel to give me miles. So I have miles, miles, and 30 miles an hour times dt is in hours, miles. So we end up with miles. And that will work. So this statement in calculus is right here. Now, another thing I want you to do is to label this here, because the labeling is going to be really important to help you keep track of everything that we're doing here. This is your rate in, and this is your rate out. And this is your initial condition. So let's get a graph of this to help us visualize what on earth is even going on. In calculus, whenever you have your x and y axis, the units should work out. So if I'm graphing the rate graphs, that would be miles per hour, if I'm graphing the rate, and on here it'd be hour. And I start off going 60 miles an hour. Let's do 30, whoops, oh my God, 30 and 60. So I went 60 miles an hour, and I did that for the first 2 hours. And then I ended up going a negative 30 miles an hour from 2 hours, 2, 3, 4, 5 here. So I had this area, and then I have this. Now, signed area tells me that this is going to be 60 times 2 is 120 positive, and then 3 times negative 30 would be negative 90. So whenever you get stuck on an accumulation problem and you're wondering, like, do I do an integral of this? Do I not do an integral of this? All you have to do is think about the units and picture a graph of it. If you're finding this area here, it's base, which is hours, times height, which is miles per hour, and it would give you just miles. So this little sketch here of what's going on here is going to be very, very helpful to you whenever you do these problems. Again, units are the most important thing that we're doing today. All right, so let's go ahead and get to our first AP Calculus free response. So this free response happens to be from the year 2000, right around your birth year, maybe the year before. So I want you to tape it down in your notes. Don't just let these flutter around like snowflakes in your notebook. Tape them all down because you're going to get a lot of them. And I want you to pause the video and read it and circle your rates and any other important information you're seeing here. So what I've done here is highlighted all the rates in yellow. I've highlighted amount in blue and my time in green here. So basically we have a rate in, and then we have a rate out. So you have to really read carefully here to decide what is a rate and what is not a rate. And you have to distinguish rate in and rate out. So, and here's my initial condition. Ready? At time 0, I have 30 gallons per hour. Initial condition. Okay, so they're saying how many gallons of water leak out of the tank in the first 3 minutes. Now look, this is out, and the out function is this, but this is in gallons per minute, and I just want gallons. So how can I turn this into gallons? How can I gallonize it? So what I'm going to do is think, okay, if I have a rate, how do I go to an amount? And oh, remember the integral of a rate is an amount. So let's do an integral of the rate. So I'm going to do an integral, and you need limits on your integral. Well, we only want it for the first 3 minutes. So 0 to 3 of my rate out. Don't forget your dt. And let's go find it. Okay, so this is t plus 1 to the 1/2, remember? And let's see, if it's t plus 1 to the 1/2, that'd be t plus 1. Let's add 1. Divide by 3/2, so times 2/3. I don't have to worry about u sub because the derivative of t is just 1, so it doesn't really do anything. So 0 to 3. Okay, so let's go ahead and plug in. This was a no calculator problem, so it's some good mental math. I have 3 plus 1, which is 4. So 4 to the 3/2 minus, normally, no, I shouldn't say this. Sometimes when you plug 0 in, it ends up just being 0. And in fact, this year, a lot of people got this question wrong because they assumed when they plugged 0 in, they would get 0. But check it out. 0 plus 1 is 1. 1 to the 3/2. So you have to be careful. All right, 4 to the 3/2, that is the square root of 4, which is 2. 2 cubed is 8, and 1 to anything is just 1. So 7 times 2 is 14/3. A lot of people got 16/3 that year because they forgot about this here. Okay, and units, gallons, because I had gallons per hour. Oh my gosh, I had gallons per hour times hour, which ends up just being gallons. Cool. Part B, how many gallons are in the tank at time equals 3? Okay, well, this is really similar to this right here. And if you could do that, then you can do any accumulation problem, remember? So we want to think, okay, how many gallons did I even start with? Well, I started with 30 gallons. I need to talk about my rate in and then my rate out. An integral of a rate in will give me an amount, and an integral of a rate out will give me an amount. So let's go ahead and write it out. Now you have to be really careful here because my rate in is just 8. So you just have to put 8 here, not 8t, just 8. And look how wonderful this is. AP is helping us out here. We already know what this is. We did it in part A. So let's do as little work as possible here. 30 plus, now the antiderivative of 8 is 8t from 0 to 3 minus, well, let's just pull this answer from A and get 14/3. So that means I have 30 plus 8, plug in 3, 8 times 3 minus 8 times 0 is 0, minus 14/3. So 30 plus 24 minus 14/3. Now you might have gotten 24 and you might think, why the heck do I even need an integral? Because 8 gallons per minute for 3 minutes is just 24. You could just jump to 24, but it's good to talk about a rate in. And oh my gosh, I realize that this is minutes, not hours. Not that it's the end of the world, but units are the most important thing we're doing here. So let's keep our units right. It's minutes. Anyway, 30 plus 24 is 54. Minus 14/3. And with some common denominator work right here, we get our final answer, 148/3 gallons. All right, cool. So the next video is accumulation 1 and then accumulation 2. They're going to pick up with part C, and then you have an extra free response to do at the end on the heating oil. So make sure you've taped this thing down and continue in the next video. All right, have a great break. I'll see you after. Bye.